Pitless equipment, the safe, sanitary way to finish a water well. Sanitation, savings, satisfied users. This is the story of how sanitary well pitless adapters and pitless units can help achieve all three of these goals, of the many ways adapters and units can benefit the consumer. This report is brought to you as an information service of the Pitless Adapter Division of the Water Systems Council. Pitless adapter well construction, it's the modern way and the better way to complete a sanitary, economic well and water system. Let's start with a question. Just what is a pitless adapter? Or a pitless unit? You've probably heard the terms. You may know quite a bit about pitless equipment. However, it's surprising how many homeowners, health officials, and dealers are not familiar with pitless equipment, what it is, how it works, and most important, why it is the best answer to topping off a modern water well. Pitless adapters and units are designed to be attached to the water well pipe and casing. Note the certified watertight seal on the casing. Later, we'll have more to say about this symbol of quality. Pitless adapters and pitless units provide a sanitary, quick disconnect unit at the wellhead. They prevent entrance of contaminants from surface or near surface sources through the adapter connection into the well or potable water supply. They are designed to terminate the well casing above the ground surface. Pitless adapters and pitless units also conduct water from the well. They protect the pump water lines from temperature extremes, especially freezing, and permit access to the well and to water systems parts within the well without exterior excavation, digging, or disruption of the earth. Pitless adapters and units are designed to replace the well pit, well houses, and buried well seals. The well pit may be unsanitary. Pits and improperly installed well seals literally invite or funnel drainage into the well from possibly contaminated surface and near surface sources. Well and pump houses are an even more expensive solution. They are costly to build and maintain, seldom are attractive to look at, and are also costly to heat in colder climates. In cases of power outages, pumps and piping can freeze even in heated well houses. Buried wells and well seals can be a real problem too. Well seals are inexpensive, true, but if they are buried, extensive and expensive digging may be needed to locate the well when service is required. Pitless units were first designed for use with a working head-type pump. The unit was followed by adapters when new designs were developed for jet pumps. Finally, when the submersible pump came into the market, there was perhaps some resistance to installing a pump and motor in the well, without easy access for removal and service. New adapter designs, like these, were developed to provide for easy location and servicing of the well. This helped overcome initial resistance to the now popular submersible pump. Thus, pitless adapters and units were developed to divert the water from the well and pump to the tank, to protect against surface water contamination and freezing, and to establish the location of the well to allow easy servicing. There are two types of pitless equipment on the market today: the pitless adapter, which is assembled in the field, and the pitless unit, which comes from the factory as one piece of equipment ready for installation. There are three basic adapter designs: compression gasket, saddle compression, and the weld-on style. The following sequence shows the steps and parts involved in putting together a compression gasket adapter. Here, the parts are put together in the well casing and against the side of the well casing to achieve optimal adapter performance. First, the slide is lowered and installed in the casing with the inner gasket in place. Then the outside gasket is installed. Next, the washer and nut are installed. The pitless adapter is now in place. The installation is complete. Now let's put together the second major type of adapter, the saddle compression adapter with internal compression. First, the saddle is installed with a gasket and U-bolt. Then the internal part is moved into the well for the predetermined depth. Next, the internal and external parts are matched and tightened. This is a front view of that adapter. Another saddle compression type is the submersible pitless kit. Once the saddle is installed at a predetermined depth, the internal part is put in place. The third major adapter type is the weld-on. Here are samples of weld-on adapters. This is a cutaway view of a weld-on adapter, with the internal elbow being lowered into place. And this is a front view. To get a better understanding of how an adapter functions, let's look at the installation process. Here's the top of an installed well casing in the southwestern region of the United States. Pitless well construction is especially popular in the South for sanitary purposes, even though frost protection is not needed. Here the dirt is removed from around the casing down to the level where the adapter connection will be made. The backhoe can also dig a trench for the discharge and electrical service lines to the point where the storage tank is located. After the dirt has been removed, a hole is cut for the discharge connection in the casing at the proper level, below the frost line. Then the adapter is installed. Here's the complete installation with the adapter, piping, wiring, and motor control box. A buried pressure tank is shown next to the well, ready for installation. Finally, the pitless well cap is sealed and the excavation is filled. The ease of maintenance provided by pitless construction is shown here. By simply removing the well cap, the system components can be raised with the drop pipe for servicing. Here are some samples of adapters manufactured by members of the Pitless Adapter Division of the Water Systems Council. And here are several more. Now, let's look at pitless units. As the name implies, pitless units come from the factory as one piece of equipment, ready for installation. Like adapters, pitless units prevent leakage of water into or out of the system. But why do some prefer selecting units over adapters? It's because they prefer to deal with a factory-assembled and tested piece of equipment that relies on only a minimum of work to make a proper field installation. Let's see the various types of units available and their individual parts. First, we have a pitless unit with an internal spool. The unit is cut at a predetermined depth, and the discharge spud is welded in place at the factory. Then, the spool is started down the well casing with O-rings installed. Here's a cutaway view of a complete pitless unit with the spool in place. There are also similar units with an internal compression attachment. Here's a complete pitless unit with a watertight cap. Some manufacturers make a combination unit pressure tank for underground burial over the top of the well. More and more buried pressure tanks are being used, especially in the South, to replace unsightly above-ground tanks and tank covers. Even though there are minimum freezing problems in this part of the country, the adapter is used for a sanitary quick disconnect installation. The entire pump and pressure tank combination can be installed underground. Here we have a better view of an underground pressure tank unit installed directly over the well. The adapter is in place, as well as the water connections leading to the building. Above ground discharge is another type of unit. These are connected to the top of the well casing above the ground level. Like complete units and below ground adapters, the above ground discharge provides a watertight seal for the potable water line. It is also easily removed for service and can be used with a regular inside basement tank. Here's an above-ground unit installed. Now, let's see the installation of a pitless unit. The first step is to dig around the top of the casing to, or slightly below, the freeze line. The hole should be big enough so that the installer can move freely, as well as cut the well casing at the attachment point. The factory assembled pitless unit is now ready for installation. First, the inside components of the unit, including O-ring seals, spool, and check valve, are removed. Next, the unit, without the internal parts, is carefully lowered into the ditch. Then, the spool is connected to the drop pipe. The unit is then firmly connected to the well casing, and the discharge line is connected. Depending on the brand and the manufacturer's design, this may be done by threading, welding, or compression gasketing. Compression gasketing was used in this installation. Next, the pump is lowered into the well casing, along with the spool. Attachment of the well cap completes the installation. Note the cable extending from the cap and well. The well, pump, and pitless unit are now ready to deliver a dependable water supply to the homeowner. The excavation is then filled. A two-man crew can complete this type of installation in less than 3 hours, from groundbreaking to backfill. Pitless well construction is easy, fast, and neat. Installing pitless equipment offers lots of advantages for the homeowner and the contractor. Not long ago, pitless well installations were concentrated in the north region of the United States. Industry insiders thought of adapters and units primarily as an antifreeze device and a means to eliminate the well pit. Now, contractors, dealers, and sanitarians realize that pitless adapters and units offer many important benefits in addition to protection against freezing, like sanitation, low cost, easy access, and long service. This is why we now see a growing number of pitless adapters and units in all areas of the country. Important symbols of product performance are the certified watertight seals of the Pitless Adapter Division of the Water Systems Council. These seals, which you have seen throughout our presentation, are visual evidence that the adapter or unit has met the exacting test required under the division's recommended standards, PAS-1 and PAS-2. Certified watertight products meet or exceed the watertight requirements of PAS-1. These standards were developed in the mid-1960s to ensure application of sound principles of pitless equipment construction and installation. Pitless Adapter Standard PAS-1, when developed in 1966, defined precisely what adapters and units are and what they do. It spells out requirements for temperature protection, internal clearance, methods of attachment, and especially how they will be tested for performance. Testing requirements are precise. Watertight internal surfaces, for example, must withstand a gradual increase in pressure to a minimum of 150 psi for a 1-hour period without water leakage. Other test requirements are equally rigorous. In addition to PAS-1, division members felt a need to develop a companion standard, PAS-2, for watertight well caps. Development of that standard began in 1985, and the first edition of this standard was approved and adopted in 1988. Pitless adapters and pitless units, the modern way for sanitation, savings, and satisfied users. For more information about the contents of this report, including copies of Pitless Adapter Standards PAS-1 and PAS-2, and a current certified watertight product list, contact the headquarters office of the Pitless Adapter Division of the Water Systems Council. And be sure to look for these symbols of certification. They are your assurance and the consumer's assurance of quality pitless equipment.